Did you know that the concept of solutions dates back thousands of years to ancient civilizations? People have been dissolving substances in liquids to create useful mixtures long before the scientific understanding of solutions emerged. For example, the ancient Egyptians used a solution of natron, a mixture of sodium carbonate and sodium bicarbonate, in water for various purposes, including mummification. We are going to explore an intriguing topic in chemistry: solutions. Solutions are all around us, from the sugar in your morning coffee to the fizz in your favorite soda. Let's dive into the world of solutions and discover the fascinating aspects that make them so essential in our daily lives. What is a solution? A solution is not just a random mix of substances. It's a homogeneous mixture of two or more components where the particle size is incredibly tiny, smaller than 1 nanometer. This means that all the components in a solution are uniformly dispersed. It's the reason why your entire bottle of soft drink tastes the same from the first sip to the last drop. Solute and solvent. In a solution, we have two key players: the solvent and the solute. Solvent. This is the substance that makes up the majority of the solution, the big boss, if you will. For instance, in a saltwater solution, where water is the predominant component, we call water the solvent. The solvent also determines the phase of the solution. Solute. The solute is the lesser quantity component, playing a supporting role. In our saltwater solution example, salt is the solute. Keep in mind, there can be more than one solute in a solution. Different types of solutions. Solutions come in various flavors depending on the number of components they contain. Binary solution. This type contains only two components. Think of a solution like salt in water. It's binary because it consists of salt, solute, and water, solvent. Similarly, it is called ternary and quaternary if it is composed of 3 and 4 components, respectively. Let's solve a quick question to revise what we have learned. Which of the following is a binary solution? The correct answer is option A, salt solution in water. The solutions comprising of two components are called a binary solution. The two components are sodium chloride and water. Dilute solution. Here, we have a small amount of solute dissolved in a substantial quantity of solvent. It's like a drop of food coloring in a glass of water. The food coloring is the solute, and the water is the solvent. Concentrated solution. This is the opposite of dilute. It contains a significant amount of solute. Imagine adding several tablespoons of sugar to a small glass of water. That's a concentrated solution. Properties of a solution. Solutions have some unique characteristics. A solution consists of a single phase, making it a monophasic system. This means that everything in a solution is uniformly blended, creating a seamless mixture throughout. Now, one of the most intriguing features of solutions is that they exhibit uniform properties. This means that regardless of where you sample the solution, be it the top, bottom, or the middle, you'll find the same properties like density, refractive index, and more. But what makes solutions truly special is their ability to defy separation by traditional physical methods. The components of a solution cannot be easily separated. Imagine trying to extract the sugar from your cup of tea once it's dissolved. It's nearly impossible. While solutions may seem uniform, their composition is not entirely definite and can vary within certain limits. Some properties of solutions, such as density, viscosity, surface tension, boiling point, and freezing point, vary with the composition of the solution. Moreover, in a solution, components may exist in different phases: solid, liquid, or gas. Yes, you heard that right. Solutions are not confined to one state of matter. So, you can have gaseous, liquid, and solid solutions. Gaseous, liquid, and solid solutions. Now, Let's take a closer look at the diverse world of gaseous, liquid, and solid solutions. Gaseous solution. When the solvent is in a gaseous state, we have what's known as a gaseous solution. But wait, it doesn't end it. Gaseous solutions can be further divided into three types based on the phases of the solute and solvent. Gas-gas solution. These are solutions where both the solute and solvent are gases. Think of it as a mingling of invisible particles in the air. For example, the air we breathe is a mixture of nitrogen and oxygen. Liquid gas solution. Here, the solute is in a liquid state, while the solvent is in a gaseous state. Picture pouring a liquid into a gas, like adding chloroform to nitrogen gas. This creates a liquid gas solution. Solid gas solution. In solid gas solutions, the solute is solid while the solvent is gaseous. Take, for instance, the case of camphor in nitrogen gas. When these two substances interact, they create a solid gas solution. Liquid solution. So, what are liquid solutions? Well, it's pretty simple. These are solutions where the solvent is in a liquid state. Imagine you have a magical liquid, and you want to mix something with it. That's where these liquid solutions come into play. But the magic doesn't stop there. Liquid solutions can be further classified into three intriguing categories, each with its own unique characteristics. Let's explore them. Gas-liquid solution. This is our first category, and it's like a magical dance between gases and liquids. In gas-liquid solutions, the solute is in a gaseous state, and the solvent is in a liquid state. Here's the exciting twist: when you crack open a can of Coca-Cola, you're actually enjoying a gas-liquid solution. That's right, the delightful fizz in your soda is carbon dioxide gas dissolved in liquid. Liquid-liquid solution. Now, for our second category, liquid-liquid solutions. In these solutions, both the solute and solvent are in a liquid state. A classic example is vinegar, which is a mixture of ethanoic acid and water. Ethanol, another essential liquid, also forms liquid-liquid solutions when mixed with water. So, the hand sanitizer you use for germ fighting is a liquid-liquid solution. Solid-liquid solution. Finally, we have solid-liquid solutions. These are solutions where the solute is in a solid state and the solvent is in a liquid state. Ever stirred salt into a glass of water? Well, guess what? You've just created a solid-liquid solution. This process is essential in everyday life, from cooking to various industrial applications. Another example is the solution of glucose in water, which is used in oral rehydration solutions to keep us healthy and hydrated. Solid solution. Now, let's switch gears and dive into the captivating realm of solid solutions. These are a bit different because they have a solid-state solvent. Let's see how they work. Solid solutions can be divided into three categories, and each one has its own unique characteristics. Gas-solid solution. First up, we have gas-solid solutions. In these solutions, the solvent is in a solid state, while the solute is in a gaseous state. One fascinating example is the solution of hydrogen in palladium. Yes, you heard it right. Hydrogen gas can be absorbed into the solid palladium. It's like a hidden treasure chest for hydrogen, and palladium acts as the keeper of this valuable gas. Liquid-solid solution. Moving on to our second category. Liquid-solid solutions. Here, the solvent is solid, and the solute is in a liquid state. A remarkable example is an amalgam of mercury with sodium. This might sound like something out of a science fiction story, but it's real science. Amalgams are used in dentistry and other applications. Mercury, a liquid at room temperature, forms a solution with solid sodium, creating an entirely new substance. Solid-solid solution. Last but not least, we have solid-solid solutions. These solutions are quite intriguing because both the solvent and solute are in solid states. A classic example is a solution of gold and copper. Yes, these precious metals can form a solution together. When they combine, they create beautiful alloys with unique properties. This is why you can have different types of gold jewelry based on the proportions of gold and copper in the alloy. What are mixtures? Let's quickly touch on a fundamental concept. Mixtures. These occur when two or more substances, which don't chemically react with each other, are combined. There are two main types of mixtures: heterogeneous mixture. In a heterogeneous mixture, you can see distinct phases, and the properties you observe are simply the sum of the properties of individual phases. Imagine a salad with various ingredients. You can still see the lettuce, tomatoes, and cucumbers. Homogeneous mixture. In contrast, a homogeneous mixture consists of a single phase where everything is so perfectly blended that it might have entirely different properties compared to the individual components. This is where the magic of solutions comes into play. It's like a secret blend of flavors in your favorite dish, the true essence of fusion. And if a homogeneous mixture can have its composition varied within certain limits, it's known as a true solution. The constituents of such a solution cannot be separated by common methods like filtration, settling, or centrifugation. So, remember, when you mix different substances, you're creating a mixture, and when you mix them so thoroughly that they become one, you're forming a solution. Homogeneous and heterogeneous mixtures. Let's continue our exploration of mixtures, specifically focusing on homogeneous and heterogeneous mixtures. Homogeneous mixture. First, let's dive into homogeneous mixtures. Imagine mixing two or more components so thoroughly that they blend seamlessly, and you can't distinguish one from the other. This type of mixture is called a homogeneous mixture, and it's often referred to as a solution. For example, when you dissolve 2 spoons of salt in a glass of water, you get a homogeneous mixture, a solution. In this solution, the salt particles are so evenly distributed that you can't see or feel them. It's like magic. The same principle applies to the air we breathe. Even though it's a mixture of different gases like nitrogen, oxygen, and more, there are no visible distinctions between them. That's why we often refer to the air as a solution. In a homogeneous mixture or solution, the composition and properties of the mixture are the same throughout. So, whether you sample the top, bottom, or the middle, it's all consistent. It's like having a perfectly blended smoothie where every sip tastes the same. Heterogeneous mixture. Now, let's switch gears to heterogeneous mixtures. In these mixtures, 2 or more components don't blend seamlessly, they have distinguishable phases. For example, think about mixing mustard oil and water. In this case, you can clearly see the phases of water and mustard oil, and they don't mix well. So, this type of mixture, with its distinct phases, is called a heterogeneous mixture. Students, in this video on solutions, we explored various aspects, including the types of solutions, the properties of solutions in gaseous, liquid, and solid states. Additionally, we delved into the concepts of mixtures, distinguishing between homogeneous and heterogeneous mixtures. I hope you liked the video.